Okay, good morning, everyone. Okay, let's start. So welcome to CCAMP session. So we just wait a few minutes to, wait for our AD because we don't know if Deborah is coming or not. So sorry about that. Okay, for the loadware, I think you all should be familiar with this information. But here, I would like to mention a few key points here. It says that by participating in the IETF, you agree to follow IETF rules and IETF process and policies, especially, patent policies. So if you're aware that any IETF contributions is covered by any by any patents, so you must disclose. Otherwise, you should not participate in the discussion in the, working group. So if you need more information, you can take a look at that documents listed in the below. So this meeting, we have only one session, yeah. So this is the right one. So agenda, so this time we have, 2 hours. So I think it should be enough for us to have the deep discussion. So as usual, we have the audio recording. So please speak in front of the mic, and also please state your name before speaking. So in this way, we can know who said something bad. Okay. Meeting echo. So I think the chairs are in the meeting echo. We will monitor, if there are some comments from the meeting echo. And yeah. So for the minutes, yeah, our handsome secretary Oscar is not here. He is always quite very busy. So if anyone could take some minutes, through ESPAD, that would be much appreciated. So I would like to ask Hao-Mian and maybe Italo, could you help us? Okay, thank you. So IPR process, this is quite very important, right? Yeah, so usually the chairs will send out IPR polling before moving to the next step. For example, before an individual draft becomes a working group document or, WG last call, we will send out the, IPR polling to the list. So if you are a contributor or, authors, so please, respond to the IPR polling as soon as possible. Otherwise, it will delay your work. Mailing list. So as always, we encourage people to use the list actively. We can discuss any technical stuff on the, on the list. For example, we can have some discussion on the open issues on some drafts, and also we could introduce some new drafts or new topics. On the list. So another important thing is that, working group, consensus is determined on the mailing list, rather than in the face-to-face meeting. So even though we could get some consensus here, face-to-face meeting, we still need to, bring it to the list, for more discussion. So for example, some people, maybe they are very active in CCAMP, but, maybe they do not have a chance to be here to the, massage place. So we have to take it to the list, yeah, to make it available for everyone. Okay.
So a short update on the status of the working group. Since the last meeting, we have a new RFC. We have our first RFC on microwave. So congratulations to all the authors and all the people that contributed to this achievement. We have now 2 drafts in the ISG processing, the WDM interface management and control framework. Actually, we just received a liaison from the ITUT on that. So authors, please make sure you address all the comments so that we can proceed. And the other one is our first young document, in particular the microwave one. We requested the publication for the RSPPT bandwidth availability document. We have quite a good number of working group drafts being discussed today, and some of them are not. So the first one is the alarm module. This draft is probably the one that has been discussed most on the list. It was 2 revisions have been uploaded. A lot of work, a lot of improvements. So there are still some clarifications to be done, but we believe the draft is in a good shape, and we are. This is probably the next draft we will issue the last call for. OTN topology is obviously. Dave wants to say something about the alarm module. Please.
Hey, Dave Sinecrope, Erickson, but speaking as BBF Liaison Manager. My understanding of the alarm draft is that it's up to version 5, which was just posted, and that the comments have been addressed. And my other understanding is that the authors are looking to send this to working group last call.
Okay.
So I don't know how the chairs want to handle that.
We did the slides last week, so it's,
that's why I'm gracing you with my voice here.
Thanks a lot. So back to the OTN drafts. We have both the topology and the T-tunnel drafts. Actually, references have been updated, and alignment with the requirements in RFC 6087 bis have been done. The first one is ready for the young doctor review, while the second one has more dependencies on the IETF draft, which is not yet fully stabilized. As we said, the RSVPT bandwidth availability is the publication for that draft has been requested. No big changes, at least we received no major no updates regarding the ID WSON ID info and encoding. Liaisons, we received a lot of liaisons, right? Yesterday and the day before, both from ITU study group 15 on the WDM framework draft, so the one that is in the ISG processing, and on the L1 CSM. So please, they are available on the mailing list. Most of them are comments against the drafts. So please review them and send your comments to the list. We are ready to start. With the transport and BI document.
Thank you. I'm Italo Busi. I'm presenting on behalf of the design team. A status update of the work. Okay. So a quick recap about the scope of the design team, which is to develop use case and gap analysis of how the IETF young models can be used to address a multi-domain optical transport network, and to check and provide guidance about how to use them. We work via mailing list and conference call, and we have a GitHub area where we track progress and open issues. We have updated the applicability statement document to the version 03. What we have done in this new version, we have put some text to clarify the scope of the scenarios that we are analyzing to address some of the comments that we received during the last IETF meeting. And we have added text for security and management, and I have also refined some of the existing text in the document to make it more clear and better editorial. We have been able to complete the editorial example, the JSON code example for the topology, and in particular, we have developed some assumptions of how we can use I2RS and T topology identifiers. It's an example, and we are also considering whether there may be a good idea to have some registration of some URI schema to give an idea to the guy who read the topology about what is the rule that is used to create these URIs. It's under discussion in the design team, and we have decided to change a little bit the way we assume the PNC abstracts the topologies. For mainly reason is simplification of writing down the JSON code by hands. And we have used the new tool developed by the NetMod working group, which is recently adopted as a working document to fold the JSON code, because JSON code lines were too long. They didn't fit into the RFC format. And we had problems in the past versions to put this text into our document. Thanks to this tool, now we are able to do that. And we have just updated, uploaded the 04 version, but just to fix some needs and formatting issue we discovered after submission of the 03 version. So no technical change to the 04 versus the 03. Okay, a quick recap of what we are addressing is a network, which is a multi-domain OTN network. Every node here is assumed to be capable to switch in the audio layer. And we want to set up an end-to-end OTN audio tunnel and to create services over this tunnel. And we are at this moment in time, we are analyzing what's happening on MPI number 1. So we have described in the JSON how audio topology is built, and how you can set up an audio service. So an audio that starts from the customer node and transit through to the transport network, or we can set up also EPL services. So take an Ethernet interface and map the Ethernet frames that are coming from the UNI over the OTN tunnel. And the new topology assumption that we have is that the PNC number 1 provides a black topology abstraction, and PNC number 2 as well. And PNC number 3 is a white topology abstraction because it has less node than PNC number 1. That's the reason why we changed the assumption. And then when you need to set up your end-to-end tunnel, you have to create through the 3 PNC, 3 tunnel segments. Okay, what are the open issues? We need to complete the examples. We have 2 items to address, in particular, how the plug ID is used to stitch the interdomain links, and then how you understand from the TTP and configure the client adaptation between the client layer and the OTN layer. We need to prioritize a little bit what we do next. For example, we have EPL and multi-point services. We need to address the multifunction access link, the protection, and we have also some requirements to describe service modification. And we have also pending issue from a couple of IETF to look around the T topology. You have a few clarification questions we have to discuss with the T topology authors, and we will do either offline this meeting or after this meeting. And we complete almost the existing examples. So for the next steps, what we want to do is a new update to address the technical issue, to align the text with the T tutorial. We have to make sure that there is no overlapping, and if there is overlapping, we either move or potential overlapping, we either move text from our document to the T tutorial, and we make references. We want to complete the examples, and we add other examples based on priority. And we are planning a face-to-face meeting tomorrow evening at 6 p.m. Okay, and to continue, so everybody is welcome to join the face-to-face meeting. We will announce the room. We have a room, so we will announce that on the mailing list. That's complete the presentation. Thank you.
Thanks a lot. Questions? So I had noted down some questions, but you've already replied to them in the next steps.
Okay.
I've seen that you have a placeholder for the protection configuration.
Yeah.
So I guess that's the next item that you want to address. What about the next ones? Are you Are you planning to address all of them, or is this a question to the working group? Which ones are you interested in?
It's the question is which one are you interested in and which one has to be addressed with priority. Yeah, because you cannot do everything in one shot. So
Exactly,
we need to prioritize, and interest of the working group is good to know. If something is not interesting, we can take it out. If something is less interesting, we can do it in the later stage.
Okay.
So
okay.
I understand from your comment that you think protection is one of the top priority for the next step. Okay.
As an individual, I would like to see the protection.
Okay.
Yes.
I take this input. Thank you.
A general comment. So the draft is in a very good shape. So thanks a lot.
Thank you
for the good work. The parts that are there are very good in my opinion. So just try to understand what are the next items, if any, that needs to be addressed, and then I think we can close this work and progress it.
Okay, good.
Thanks a lot.
Thank you.
Good morning, everyone. This is Young. I present WSUN topology and tunnel model update this morning. There's a big update since IETF 100. The first thing is we created GitHub to put all the layer 0 models across WSUN and FlexGrid into one GitHub, including impairment work actually, so that more people can participate. Actually, indeed, more people participated because of this GitHub. And one major change is across WSUN and FlexGrid, we created a common layer 0 types, the groupings where all layer 0 models can import and so that we don't have to overlap. Like node types, application code, and wavelength assignment policy, and client types, etc. And the complete augmentation of T topology model is now available, and in particular, all modules that require WSUN specific label, like a label restriction and bandwidth types. Also OTN, now they created OTN type for client type, so we actually import that. So as OTN draft is stabilized, and also T topology, now we have updated all modules to be complete. So I think our topology model is probably 20 pages, so I cannot put it all together, but it's in the GitHub, so take a look, or in the draft. So if you have any comment, please leave comment on the GitHub. So I think now draft is on par with the OTN topology model in terms of maturity and completeness. And we hope that we can move for the working group last call, but before we do that, probably Young Doctor review would be required. So if you have any comment, please address that to the list.
Yeah, so questions? It's too early, everyone is sleeping.
Dieter Beller, Nokia. I've seen that there has been some changes regarding the spectrum management. So I think previously there were the M and N values for FlexGrid as defined in G694.1, and that has been changed. I don't understand why that has been changed.
Oh, this is a WSUN.
Okay.
We're out of time.
Okay, so the T topology draft is now in the editor queue. So the dependency is somehow resolved because we don't foresee any change to the draft. So that is no longer a stopper to move this forward. I think it's now another topic to be solved was the alignment with the T types, but this was resolved. So I would say it's now good timing for the young data.
Okay. So I think it has to be coming from the chairs, right?
Yes.
Yeah. Okay. Right. So this is just tunnel model for WSUN. I think same thing. Basically, augment IETF-T and import OTN types for client signal, and import layer 0 types for layer 0 specific groupings and an NDA compliant model. I think this information is identical as the previous one. Likewise. So I think this is on par with the WSUN topology model in terms of maturity and same stage at this moment. Okay. Right. So next one. So now this is okay, tunnel model first, maybe. I mean topology model. It doesn't matter. Yeah. Okay. Yeah, this is a media channel.
Takes a while to go to presentation.
Yeah, this is a data model for FlexGrid media channels. So I think same information applied. Layer 0 FlexGrid is in the same GitHub, and layer 0 type module share across WSUN and FlexGrid. And it's a complete augmentation of T tunnel model now in terms of specific labels and bandwidth. I think I'll get to Dieter's questions shortly. So this is just some example of that, another 20-page young model. Okay, so this one is a little bit more unstable because T tunnel model is not as stable as T topology model. So maybe, hopefully we can move once T tunnel move to RSCQ. And now pending issue is why we get away from M and N integer using a frequency. Just a style issue and style. And also WSUN, we use frequency, and CDMA, WDM is all frequency. And also, if you know label restriction stats, it's all using frequency unit. So, that's kind of, one of the rationale why NMN move, change to frequency unit. But I think Dieter and also Gabriele said for human to configure NMN would be easier. I have no preference. Maybe Iowa may have some idea from implementation standpoint. We can change NMN for FlexGrid integer or leave it as a frequency level. It really doesn't matter for me, but you can comment on that.
Gabriele Francisco. Yeah, you're right, Yang. My suggestion is to apply the 6205 that is working either for DWDM and also for SSON. So NMM can be applied also for DWDM. You just have to specify the central frequency, the channel spacing. That's it. Are all integer numbers, and then you get rid from very long fraction 2 or fraction 3 or whatever fraction digit you have that are source of mistake, in my opinion, during the implementation, not the provision. Because I'm in favor to use n and m.
In the integer.
Integer, specifying, of course, the channel spacing, like 6205. Nothing new, actually. Thanks.
So at the time when we updated the draft, so the reason we
Your name?
Iowa from Huawei. So the reason we put this into using frequency, like based on several considerations. Like first thing is at least in my past experience with all the implementation for GMPLS and WSON, stuff, all of the frequency that we use are integer number instead of floating points, because this is according to the ITU spec, right? This is one. And second is if I use N and M, I think from the implementation side, we have to convert it into frequency anyway.
Mm-hmm.
So this adds another additional level of processing, and also for the label restriction and label used in the
Right.
in the tunnel. In that case, I guess we have to expand the construct in the Young model to accommodate two parameters as opposed to one parameter. So I think from the passage, it's a little bit complex, but
So one is motion friendly and the other one is human friendly, right?
Dieter, again, frankly speaking, I don't understand this argument because there is a formula, a very simple formula in G694.1, which actually defines how to calculate frequency and slot width out of the NM and M values. It's a fairly simple formula.
So flip side is also
and
true,
if you
right?
specify frequency and slot width in terms of gigahertz, for example, you can specify any value, but the ITU2 recommendation says clearly that there are specific carrier frequencies on that 6.25 gigahertz grid, as well as the slot width is also in discrete values and not something continuous.
Yeah, so the frequency value is fixed, right? So
Yeah, so this is an issue that we need to resolve. I don't think we can resolve today, but
Let me clarify a little bit. Frequency value are not fixed. So depending of what is the granularity, you have fraction 2, 3, 4, 5 digits, and that is the source of the mistake.
okay.
yeah, so I haven't experienced that fractional difference, but if that's the concern, I guess we can think of putting back into NNM. But the only thing is in the constructs for augmentation, I probably have to look into how we can put both parameter in the label restriction, because this is a range, right? And this range needs to be extended to support a combination of N and M as the starting and ending. So
Maybe we can create some conversion table into the model, and
I think the conversion table is already inside the 698.2.
yeah, I know. So maybe that might be a good compromise, and whichever you want, you can take. But modeling perspective is not that obvious, especially of wavelength restriction when you model range. So it's not that simple, just integer. So I think that's Iowa's point. So let's discuss offline. Okay.
Huawei. An editorial comments on the draft. I think some of our drafts we are using the term flexi grade, and sometimes we use flex grade with or without a capital I. So please just make it consistent.
Yeah, I think it should be flex without I, right?
You have this.
This might be not the real document name. What is the real document name? I
But
probably
if you-
typed it.
If you refer to the previous RFC on the FlexiGrid control, there is an I.
I?
Yeah.
Okay.
So-
You know, the main also, Jorge said, I don't want I. So I don't know. So maybe you can talk to him. Yeah, I'll make it consistent. You prefer without I, right? With I. Okay. Okay. Okay.
You did the media channel, and now we have to.
No, I just did, right?
Okay.
The same thing, yeah. This is a layer 1 connectivity service model. Okay. So just related modules are the main module IETF103-CCAMP, it's a typo, CSM. And we create a separate service type for layer 1. And we also import IETF young types. Again, GitHub is created for layer 1 CSM model as well under ACT and CMI. So if you have any comment, please visit this site and leave your comment there. Changes since last IETF is basically pre-working group last call, young doctor review is completed. And thanks to Rob, I believe Colton, right? And changes are incorporated. And I just met him today. He said he will reply to this comment to finalize it. And substantial editing effort has been placed to be ready for working group last call. And thanks to Tom Patch, he was very thorough to make sure that we have all the formats and standards that Young requires and all the references. So.
Adrian Farrell, just for the minutes, not Rob Colton. Rob Colton is a great OSPF jazz guitar player. Rob Wilton.
Rob Wilton, okay. Thank you. Yeah, I know Rob Colton actually now. I remember him. Okay. So this is a very simple service model that describes connectivity of layer 1 in terms of access and services and service instance. So I believe this one is really ready for working group last call. And
just one comment, Yang. So we just got a listation from MEF. So it says that MEF 63 just published. So you should double check if you have alignment with that published document.
Yes, actually, this is based on MEF 63. When model was developed.
I know because you just reference to the previous version. Maybe there are some changes between the latest one and
yes,
the previous one.
I checked. Yeah, but I'll do once more and make sure that it's consistent.
Dieter Beller, Nokia. May I suggest to send a liaison statement to the MEF and ask them for comments, whether this is in full alignment with MEF 63?
That might be a good idea.
Thank you.
And you guys, right? Okay.
Just volunteered to start writing the liaison. Thanks.
So in terms of process, what do you want to do?
We go for the liaison now.
Okay, all right.
We already did
No, I
the
mean,
young
that's-
doctor review, so
Yeah.
once we check the BBF liaison, we go with the MEF liaison. I think that
Okay.
we are done.
Okay. In addition to the liaison to be sent to the MEF, is there any other comment you wanted to raise before we decided to move on with the draft? Okay. It's you again.
I'm sorry this morning, but this one is a real exciting one.
This is the most exciting, right?
Yeah, this is new work to.
Wait a second, it takes a couple of minutes to go to screen.
Okay. Yeah, this is actually a continuation of our layer 0 model we call optical impairment aware topology model. Actually, when Hamian and I published in secret, many people already jumped on comment, but that didn't mean to be completed. And we even changed the name of the draft from WSUN to optical to convey that this is not just fixed, but also flex grid. So we had a lot of offline meeting even before we came. And yesterday we had a great meeting with all those authors and contributors and working group chairs. The intent of this document is to provide young data model that can be utilized by MDSC to collect state of optical impairment data from transport PNCs to enable impairment-aware optical path computation according to ACTN architecture. So draft is built on RFC 6566, which is a framework for impairment, and it supports both WSUN and FlexiGrid, also known as SSUN optical networks. There are other information impairment validation model that proposed by Gert and Gabrieli and other people. I think they will present later. The difference is this is a network model, and we want to base T topology and WSUN and FlexiGrid topology, the installment that the CCAM and Ts have been building, so that it's not just interface, but it's a TE model. So that's, and also it uses layer 0 types, common groupings that we just defined in WSUN and FlexiGrid, so that it can be consistent with, from modeling perspective, it's just another augmentation of that. So model, I think T link attribute is we augment that to describe fiber. Don't bear with this parameters yet because this is work in progress. We just show as a sample. And we also put some, when light path is created, we put some which label that corresponds to and what are the parameters, but this probably not the topology model. So this might be tonal model. So when we have tonal model for impairment, maybe this part will move to there or not. I'm not sure at this moment whether we need the impairment tonal model as a separate model. I don't know. Yeah, we may be able to use WSUN tonal model or FlexiGrid tonal model. I don't know, but we'll discuss that later. Yeah, this one is what people have different views. This is tonal termination point augmentation from TE topology model to describe transponder. So we have available operational modes, which is I think least, and then which one to choose, and then one of them is IETF 698.2 code. And there's some other information, but this one is unsettled. People debate whether we have to have explicit, attribute defined, or application code or modification of that will be sufficient or not. So just to give you a background, this is application code G.698.2, and as you see here, B means bidirectional if it's one, and D is DWDM application, and so on. But if you look at Y value, it takes NRZ 2.5 gig or NRZ 10 gig. So this is quite outdated. It doesn't address coherent optics. And also fiber types are also limited, and FAC can be added to indicate FAC encoding. Nonetheless, so the issue is that the current application code was limited, but recently, I think last month in the IETF meeting in Geneva, they actually proposed adding 100 gig DP, DQSP, SK to be added on the Y value, which is optical tributary signal. So they are moving along to address at least 10 gig, but not 400 gig yet. Yeah, not 400 gig yet, yeah. So this code is now, at least it addresses 100 gig, which is better than previous version. So I think the issue is how to model IETF application code versus vendor specific. If you recall the WSUN draft, we actually allude that in the future, vendor specific code can be added. So if this code plus some additional parameter need to be added, I think we have freedom to do so. And another issue is a vendor specific is a good name to accommodate non-ITU code, such as like organization now open config, they have their own code and so on. So, okay, Igor?
Igor Bruskin, Huawei. So I have a bit of a problem with the architecture of setting up, say, multi-domain optical trail that goes without strictly in the optical layer goes through multiple domains. Okay, in my opinion, basically, don't you have to solve all these disintegration problems that you need to solve when you disintegrate optical termination from optical line? When you also do, for example, disintegration of optical line itself and connecting, say, optical segments provisioned in different domains by different vendors. Okay? It's not only about application codes and modulation codes, right? FACs and stuff like that. You'll have to consider all the parameters that needs to be considered, right? When you try to interconnect alien wavelengths.
Yeah, actually, current scope is a OLS segment, at least within one OLS segment, how we use application code to set or configure transponders from different vendors. I think that's actually narrow focus, and I think you are addressing a bigger problem that optical network since day one has been facing. So that one, I don't know. Maybe Gert may have some answer. You're about to.
Yeah,
No?
my question is to the chairs. Okay, so do you think it is reasonable to consider, say, ACTN multi-domain scenario when MDSC controls optical tunnel, okay, that goes through multiple domains? Start on one termination point, goes through one domain, then another domain, then third domain, and then on another termination point. So in a similar way as we consider, for example, OTN tunnels.
Well, actually, it's not a question for the chairs, but it's a question for the working group.
Yeah. You
become like Lou.
Yeah, this shows my respect to the chairs.
I learned how to not to answer questions from yesterday. No, I enjoy.
So yeah.
I mean, as an individual, I wouldn't spend much time on that.
Yep.
But this doesn't mean that we don't need to work on this, in the sense that You might have multiple optical domains controlled by the same MDSC, but controlled individually, in the sense that you don't necessarily need to have an optical path that spans multiple domains. But you might have multiple optical domains with trails initiated and terminated inside the same domain, but all the different domains controlled by a same hierarchical controller. This is a reasonable scenario.
But this is what you do through PNCs anyway, right? So you don't really need much coordination in the optical layer.
Yes, but okay, there are two operation modes. You use the different PNCs to set up the different connections, but why did you put an MDSC over there if you use the PNCs?
Because probably I want to use these optical trails to support my, say, OTN tunnel that I do need MDSC coordination.
Why not operating just on at the MDSC level, and do the optical at the PNC level and the OTN at the MDSC level?
So because like I said, before we can consider such a concept, we need to solve the disintegration issues, like open config style disintegration between, say, termination and optical line, before we can start even considering multi-domain optical lines. No?
Yeah.
Anyway, Gert is a bigger specialist, right?
So thank you. Let's say to start with, I anyhow have an issue in general about when we talk here about domains, which are not based in technology. Because what does it mean, a vendor domain? I mean, if vendor A buys vendor B, it's a single vendor domain, but the technology is still the same. So what are we doing really? So in theory, I believe we should work here under the assumption as if there's a certain technology with, independent of any vendor or producer, and that we need to set up a, let's say, a trail to that. Now, how that is mapped to a real application where you have different vendors and there are different controllers and they do different things is certainly something that need to be discussed, but probably not with that one. I think we should really work here as we talk about technology, we talk about nodes, and if vendor A or vendor B, who cares?
On slightly different topic, I was asking about the augmentation because the current model suggests to augment directly from the T topology, right? Well, I think that for optical impairment, it applies only to fixed or flex grid, and it's optional parameter. So do we consider augmenting instead of from T topology, augmenting W sum and flex grid models?
Yeah, actually, that's a fair statement. When this model was worked out between Hao-Mian and me and my colleague in HQ, flex grid model was not stable. So, and also this one addressed not only fixed or flex. That's why we did. But I think your point is well taken. We can augment both WSUN and flex grid on a separate augmentation, and we can duplicate the work. That's what you mean, right?
Yeah, so we probably have to see, what kind of information we have to duplicate or not. I mean, maybe we can use the same grouping for both augmentation. It's just that we need to write two augmentation statements.
Right. I keen on contribution from you.
Yeah, well.
Okay. Yeah. All right.
So Rüdiger Kunze, Deutsche Telekom. So first of all, so this work here is really appreciated from the operator side as well. Coming back to Igor's point, so there are several use cases where we can use colored interfaces or this kind of technology in the network. So having this kind of interfaces in a simple peer-to-peer connection in the aggregation or backhaul network, as well as Igor addressed in a multi-optical domain scenario. And there are not all points or issues covered yet in that case, but for certain other scenarios that we can run in the network today, this work is really appreciated. Thanks.
Yes, I would like to say that I agree with Igor that you cannot, today with the technology, you cannot span an optical domain, an optical path to multiple domains. But I also agree with Daniele, you can create an end-to-end ODU and then trigger the optical path set up by the PNC through the MDSC. So I see in a multi-domain optical network still available to have the ACTN architecture. But of course, you have to go through 3R regeneration between one domain to the next, and this is the job of the MDSC.
Okay. Okay, let's continue on. I think this one is the one we need to augment WSUN Flex Grid model. I think that's what I was comment. I will work on that once this is a good idea to go on. And another one is, I think this is Jonas Matheson at Creo. He commented whether we're going to model not OLED itself, but OLED span, because one fiber has multiple span, and to capture power and OSNL on each segment might need to be modeled. I don't know yet, but if there's enough interest, we can do that. But today's model doesn't support that. And also, he also mentioned that there are advanced FAC modulation type, and OpenRoad MSA, they define 100 gig DP QPSK with staircase FAC. And upcoming OIF, they also define 400 gig DP 16 QAM with Hamming SD FAC plus staircase HD FAC. I don't know what that means, but there are different proprietary versions coming down the pipe. So just want to give you some heads up what's going on in industry. So next step, I think if this is a good idea, we can refine the model, and also we can work with other drafts. And then this one is actually exciting thing. This is outcome of yesterday's offline discussion. And I noticed that there are two camps, depending on where the device configuration is located, whether it's a part of controller or part of device management, with it like EMS-like fashion. So if there are two modes, operational mode by domain controller, that means device configuration is outside of domain control, so that those yellow line is kind of simple operational mode. But if device configuration is residing within SDN controller, then the information that you need to configure is much more detailed. It's colored as a blue. So depending on which one is your implementation, we have to support both model look like. And then this is Chair's rendition of those information into this good summary. Look like we can do both, and I think the draft Taharini DW interface might fit in device configuration to the transponder block. That is outside of and the scope of this document that I'm presenting is actually initially for PNC to MDSC. So this is more operational mode. MDSC doesn't need to configure or know those details. So maybe I think I'll give Daniele to kind of elaborate a little bit more and how we're going to move from now on.
Igor Briskin. So my question, another question is that according to ITOLA, the reasonable scenario is that you are setting up, say, OTN tunnel going through multiple domain, and just to support the segment of this OTN tunnel, you might trigger, say, optical trails within each domain, which fully contained within the domain, right? So if this is correct, then I also heard that at the beginning of your presentation that unlike all other presentations, this one is exciting because you are collecting optical impairment information from different domains. So if the optical trails are fully contained within the domain, why this needs optical impairment information? Does make sense? So I would say that you collect this optical impairment information because you want to compute optical impairment end to end, right?
Good question.
Yeah.
Is it like even in a single domain, you need to understand the operation code of both ends in order to find a match within a domain, right?
Yeah.
Gabriele speaking. Just to clarify the question from Igor, you might have different kind of, let's say, accuracy in the optical impairment calculation, either in MDSC and in the optical controller, in the optical domain controller. That's why we have two different kind of parameters that are shared. No? And of course, nothing prevents MDSC to have, let's say, a very high level understanding of whether a circuit, an optical circuit may work, and then go forward asking the confirmation to the optical domain controller. While the optical domain controller, being probably vendor specific, can really check and bless what MDSC is asking for.
A pre-check.
Sorry, still doesn't make sense because say I'm doing whatever I need to do inside my domain to support my OTN segment. Okay, so I could even assume quite safely that whatever calculations are happening because it's done by PNC, it could be very well proprietary to this domain. Okay, like for example, in ADWA we did computation which are totally different from commonly accepted computation of the optical domains. For example, we never used optical code, application codes at all. We simply computed the optical impairments based on the engineering rules provided by our optical engineers. Okay, and so what I'm trying to say is that what MDC has to say, why MDC would care about the optical impairments inside the domain. So what kind of preference it can actually specify.
Thank you, Italo. I think the use case here is slightly different than the previous one. I tend to agree with Igor. In this situation, I don't think we need impairments between the MDSC and the optical domain controller because the optical domain controller can take control of all the optical path, but maybe we need the impairments on point number 2 between the optical domain controller and the transponder, because if the transponder is not of the same vendor as the OLS segment, then the optical domain controller needs this model to understand how to set up the transponder. Another scenario I've seen is that in some cases people want to have the two transponder controlled by the MDSC, and that's where you may have also another value of this document. So it depends on the network scenario that you want to address.
Yeah, I think actually the last slide is not completely accurate in terms of color. You agree? Yeah.
Okay, depends on. But there
so
are.
I think basic idea is that we need to encompass these two mode of operation, and depending on which one we choose, the details are determined by that. And I don't want to talk about multi-domain at this moment, right? Just single domain, whether this works or not. And then I think Igor's question is valid when we have multi-domain.
Yes.
That's a different issue.
I don't believe you can have multiple OLS domains between the two transponders.
No, this is a single domain picture.
The problem is that you may have some separation between the transponder and the OLS segment, and that's where this model becomes applicable. So it's not applicable everywhere. It's applicable under the assumption that the transponder and the OLS are maybe under, there is some different multi-vendor requirement there.
So Gaetano, I try to come back to my earlier statement. I think one of the issues I see in particular here is that we associate a domain with a vendor thing, which, well, it might be the existing case, but I think we should go away from the notion of vendor X does this or vendor X Y does something else. I mean, the whole internet has been built on the assumption that whatever router is a router, and there's no model for Cisco or for Juniper. In that sense, I think talking about that we have two different domains from two different vendors is a non-issue for the working group. So whatever a domain is, it need to run, and then it's up to maybe a vendor to apply this to his equipment or to his solution. I kind of would suggest to get away of this association of vendor domain. I think it's really something we should not really, let's say, discuss here in the IETF.
Yeah, so thanks for the comment from Gert. So I think from the country plan perspective, domain here is mainly about administrative domain. For example, this kind of how to define the domain. It's more like a kind of operator's policy. It could be vendor specific. It also could be technology specific things, right? Yeah.
By the way, we are not working under the assumption of multiple domains equals multiple vendors. There's a single domain there with the multiple vendors, transponders.
Yeah, well,
it's a single domain and multiple vendors.
Dieter, again, I tend to agree that we should focus on a reduced scope first. So consider a single domain only, and this draft is all about topology. So we're currently discussing the scope. I think it's all about topology. That means we have to work on what the link attributes, the TE attributes are for layer 0, and identify those, specify those. We have started some discussion how we actually should model the capabilities of the termination points, which are the optical transponders, but there's a lot of work ahead.
Right.
And I would strongly suggest that we consider a simple case first and see where we can get before we actually put the scope too high or too wide.
So if you think about this IP network, they really consider it as multi-domain, right? It's usually a single domain, single controller, and many devices happen to work in the same domain and in an interoperable fashion. So this is not what happens in the transport world. Okay, the reason why we have so many domains, in my opinion, is predominantly because each vendor has its own solution. Okay, so I cannot see like you have like two domains there, in each of these domains, Huawei works with Nokia. No one will set up such networks at all, right? So the reason why GMPLS is deployed, this is exactly the reason that we can actually handle the network as a multi-domain, multi-vendor. In my opinion, it almost always the case. You can multi-vendor, multi-domain. So you have one domain which is Huawei domain, another domain is Nokia domain, and we have an interoperability solution, say through northbound interface, how to deal for these cases. Okay, it is not like we have an administrative domain, and I get to choose those devices that are better in this respect, so I put them in this domain.
Okay, so I just want to ask chairs and working group, is this good work to be done here? And if so, then we are motivated to, as Dieter said, to not only focus the scope and then work on it and progress. Just want to ask you.
For me, the answer is yes. For the working group? So let's do a polling. Who believes this is a topic we should work on?
Count me too.
Almost everyone.
Okay, thanks.
So, can we quickly go through the
the last slide, the one on how should we. Okay. Because who doesn't believe that we should spend time on this work?
So my big question is, my question is, do we really need to come here and discuss a single domain, single vendor solution? Okay, so how long we should keep dancing about the issue that if we are talking about like a single domain, single vendor solution, it is good to know about how things happening, but it has nothing to do with standardization.
How about Igor? We are talking about multi-vendor transponder. So it's a multi-vendor environment. It's not the whole box, but component of optical box is now provided by different transponder vendors.
If you are talking about, say, open config style disintegration of terminal device versus optical line, that's a good important thing to discover,
right?
And to work on.
Right, that's the focus of this work. Not only focus on that.
So I'm sorry, Adrian. So I also have one comment on Igor's question. So actually, I think right now more and more people, especially some operators, our customers, they are looking for some solutions for the multi-domain, multi-vendors, So this is why we are defining ACTN or young models for those kind of things. They are trying to find a kind of open interface for that. So if we are just trying to solve some, think domain, think vendor solution, I think, of course, we are not doing this kind of thing. Yeah.
You are talking about multi-domain, multi-vendor solution, right?
Yes,
right?
Because, for example, even you just mentioned the alien wavelengths. Alien wavelengths is also a kind of, multi-vendor topic, right? So if we are, and also alien wavelengths could be applicable to this kind of.
And I totally agree
topic,
with you,
right?
but I also hear, let's concentrate on the single domain, single vendor solution.
No, we never said that. Nobody said that.
Adrian Farrell. So I'm not going to say let's concentrate on a single vendor, single domain solution, but I want to say that there is some benefit in having a core standard approach that single vendors can pick up and use. And that benefit lies with the operator having a common understanding of how vendor domains work. And the ability to transfer knowledge and the ability to have a common diagnostic approach. And much though we all hoped that GMPLS would be a multi-vendor, multi-domain, end-to-end solution and everybody would be plug and play interoperable, I don't think we got anywhere close to that. But GMPLS is seeing quite a lot of deployment in single vendor domains, and the benefit there is definitely visible in it being a standard.
Right, I think I fully agree with the agent. Even in a single vendor, single domain case, the user will need to understand the optical layer behavior, optical performance, as well as be able to influence the choice of paths and operation code and stuff like that.
Right.
Okay.
Okay. Hi, this is Chile from IETF. This draft is about it's about the GMPS on beyond 100 gig. It's an applicability draft. It's because, but this is not the first time we present this. It's because according to comments from working group, I think it's London meeting that if we think that there is no protocol extension existed, we don't need to update the framework document again. We need to submit an applicability document. So we just submit a new document to do this. Okay, next. And this slide is about the scope and aim of this draft. The reason that we stopped to update the framework document is because we think some uncertainty about how to configure audio saying link still exists, and this uncertainty I think may have some relationship with the progress in other SDO. So just after discussing among the authors, we think we should limit the scope to how to set up audio K and audio flex ISP over configured audio saying link. So currently, we think that how to configure audio saying link and not in the scope of this draft is for future work currently. So the aim of this draft is to evaluate whether we can use a current defined GMPS mechanism for audio K to apply that in the audio saying link in this case. So this is the aim of this draft. And next, okay. In this draft, in this slide, there's some comparison between the OTOK and the audio saying case. After the discussion, we think that are similar to ODOK or OTOK T-links. We think in this case, audio saying links can also be represented as one T-link. You can see that from the fingers below. The left is the OTOK and the ODOK case, and on the right side is the audio saying case. We think in this case, to resolve the T-link is able to know the T-link is supported by an audio saying or some audio case, something else, as well as a resource related information. So yeah, it's some T-link deprecation. And next, some evaluation jobs are done to both signaling and routing to see if it's if we need protocol extension to apply this to the audio saying case. After the evaluation, that we think that for signaling, the resource on the audio saying T-link can be sent by the client. We can say it's audio K or audio flex, and the label defined in IFC 7139 is able to be applied in the case of configuring audio K and audio flex ISP over that link. So I'll just give one example here that shows how to use the label format defined in IFC 7139 to do that. And this is for signal evaluation. And next is about the routing implication. We think that once the audio saying link is up, it's configured, the resources on it need to be advertised. After evaluation, we think similar to OTOK, this time it's OTOK. Audio saying T-link is the ultimate hierarchy of the multiplexing. So we think there is no need to define new signal type for this, for the OSPF T extension defined in current IFC. And as there is no new signal type introduced, we think the ICSF field carried in ICD that object, it should not be changed, it should not be extended to include that. So we think the current defined signal type that is audio 01234 or flex can cover this need. So just depends on the scope that in this draft. And for audio saying T-link, we think only one slot granularity is defined. So it's a 5G gig. So there's no need to advertise this information, as this information can be obtained by touring the audio saying link. So yeah, this is about a routing implication. Okay, so after discussion that among the authors, we come to a conclusion that we think existing protocols defining IFC, the current existing IFC for signaling and routing of audio K can be reused in the case of configuring audio ISP or audio flex ISP over audio same link. We just assume that audio same link is ready configured, it's already there. So there's no new protocol extension needed currently, we think, just limit based on the scope. And we also think that it would be useful to publish an applicability statement document that describe in details how these protocols can be reused. So yeah, okay, next step is we request for working group adoption. With regard to some content in this slide, I think some of them may not be included in the current draft. We will do that later. Okay, thank you.
Hey, Gadrama, can you go back maybe 2 slides? Next one.
Yeah.
Here. You see here in the first sub-bullet point, similar to OTUK, ODUCN is the ultimate hierarchy of multiplexing. So where do you see the OTUCN?
Actually, in this case, I don't think we need to configure OTUCN because it's one kind of section layer. It will be sometimes it will be automatic configured, so we don't need to do that. That's my understanding. Yeah, but for OTUCN, sometimes it's for OTUCN it can be configured as a result of something like a server layer. Once you finish the configuration of the server layer, the OTUCN will be up.
So my impression is that while let's say the old hierarchy, we went down to the OTU level, that analysis has kind of stopped at the ODU level. So I think for a fair comparison, we should go down really also describe to OTUCN.
Maybe let's talk about that too. Yeah.
Italo speaking. The big difference between the ODUCN and the ODUK is that the ODUK is a switching layer in the electrical domain. The ODUCN is not switched in the electrical domain. So for what is the scope of this draft, we assume that the ODUCN is set up and we have it, and this is our underlying infrastructure, server layer, and we set up ODUK over it. So the ODUCN from the ODUK setup perspective is like the OTUK.
Yeah.
I understand from mechanism perspective. So if you have a server layer already set up, you can pull up, let's say, everything on the client. But so the same you could say for the OTU. So once you set up the OTU, all the rest is kind of an ODU setup. Right? So now, but the OTU is really what goes on the line. The ODUCN goes in OTU and is mapped again. So from that perspective, there's another step to be looked at.
Yeah, we have intentionally decided that we say we have an ODUCN, and what is below the ODUCN is out of scope, because then you have the OTUCN, then you have all the optical part, so it becomes too complex. What we need is we have an ODUCN, which is a new type of link for the ODUK setup, and we want to say how we can set up ODUK over that link. And the protocol changes there are no protocol changes, but the behavior has to be described because it's not that trivial. So we are addressing only that type of problem. The problem of setting up the ODUCN is another issue which is outside the scope of this document. So what's below can be everything for what is our perspective.
So I understand that you want to limit the discussion on that level. However, my view is that this is a little bit a kind of arbitrary limit to just say, okay, the complex thing is anyway done. So let's assume it's there and then discuss on what can I put on top. So I would think that the assumption that the server is always there is probably something that needs to be discussed as well, because it's And you cannot simply say, hey, let's say my OTU is there or my OTU-CN is already there. And then from that point onwards, I have no problem. Or no problem. You show how you're able to set it up. I think the subset of the problem that needs to be addressed.
Yeah, I agree with you that it's that for that work that you just described that we will do that later, but not for now.
Gert, in the draft is explicitly said in the beginning there are two types of scenarios. In which scenario? One scenario is, for example, this on the top on the right, in which ODU-CN link is one-to-one granularity. So there is no problem because the setup is automatically provided in both cases. This is not the case below, for example. And we decide, since there was, when we discussed these drafts, there are some not decision also to level from all the photonic part that is still instable. So we decide to look for the electrical applicability. And this electrical applicability is provided as soon as you have ODU-CN link already provided. So it is not in the content of this draft to take into account how to set up the ODU-CN link in some scenarios. And this scenario is described in the drafts.
I mean, my point is that also the OTU-CN is electrical.
Currently, it's not in the scope of this draft, but
I understand that you included it from the scope of the draft, and that's your decision. But let's say the line you've taken to say what is in scope, what is out of scope, is in the middle of the electrical ODU-CN to OTU-CN adaptation, and I am simply questioning that part of it. And I mean, you did a great work for ODU-CN above, but I find it a little bit, let's say, arbitrarily to have this line.
Yeah, I think something we need to consider some progress in that still, and based on this. Okay.
Okay, actually, I have one quick comment to confirm. Yeah. So, do you mean that there's nothing new to be extended, or some minor changes still needed?
I think nothing new currently after the evaluation.
But could you go back to the label format? Yeah. So if there's nothing new, how do you know ODU4 is multiplexed into ODU-10 rather than something wrong? How can you recognize this is ODU-10?
I think that after the ODU-10 is configured, both ends of the ODU-10 link, they know that.
Yeah, I know the load locally they can understand, but from the country plan perspective, from the network point of view, how how it can be known that this is ODU-10. Anyway, you should have some place to make it, to be aware.
ODU-10.
Because it's 100 times 5G slots.
Yeah. Yeah, it's ideally, if it's correct, they can understand. But maybe there's something wrong. Why do you know this is wrong or something correct? Right?
So explicitly
maybe
say
this map is wrong actually, maybe because of some reason.
Maybe.
So explicitly say it versus inferring from the label format.
So think about that.
Okay, that's fine.
Let's move forward now. Thanks, Shilei.
Thanks.
Did all of you sign the blue sheets?
Hello. This is Amy Yu. I'm from Huawei. So today I will do the presentation for the young data model for microwave topology. So this change in the 02 version, first we have several changes in the young models, but basically it's kind of optimization. It's not a technical change. First, we changed several types of the type of several data nodes, such as the link nominal bandwidth, current bandwidth, those are related with bandwidth, and also the availability. Then another change is that we changed the unreserved bandwidth from read and write to read only, because we agreed that those parameters cannot be changed by the user. And then we also changed the interface route, which is the mount point of the microwave radio link in the interface model, to an optional feature, because if you don't want to, from the technology model to go through the interface model, you could just ignore this. And then we have a new section. This is all according to the discussion from last IETF, to explain how this microwave topology is related with the client topology, especially with the Ethernet topology. So we conclude that the Ethernet topology is an overlay topology on microwave topology. Then there's another comment from last IETF meeting to say if there's any possibility that we could reuse those models to other technology. And actually, we could explore more. We're trying to add a new section, but we don't have any concrete test yet. And then finally, of course, we have to do some editorial improvement. So this page shows the changes of the types. First, for those, for example, nominal bandwidth or current bandwidth, we are changing the types from the RT types bandwidth IEEE floating 32 to unit 64. And the reason is actually quite simple. We want to make the life easier. So because it's kind of IEEE float point is not so human friendly, so we must convert a certain bandwidth value into the IEEE floating point coding. And then after the discussion, we would like to prefer unit 64. So that will be more straightforward. And then another change is for the availability. We changed the type from the RT types percentage to decimal 64, because in the RT type percentage, it's defined in unit 8, and it's not a node fraction parts. While in our case, our availability unit have the fragmentation parts, for example, 99.9 or something like that. So we would like to change that to decimal 64. However, I noticed that in the recent net mode this discussion, they're also considering to rewrite or have an unbiased on the RT types. So percentage is also within the consideration. So they may like to have further extended to allow the fraction part. We will follow the net mode discussion, and if we can catch up and the updated percentage is okay for our purpose, we will continue to use that. Or if not, we will keep the current definition as it is. Then for client topology and the microwave topology. Could you go a little bit down? Thank you. So the first thing is that we want to be clear that this is Ethernet topology is the overlay topology on microwave topology. It's kind of the client and the server relationship. And on the left, you will see a very simple case that the Ethernet link is supported by the microwave terminal in the underlying microwave topology, and while the microwave terminal is supported by only one microwave link. I think this is without any doubt. And there might be some problems that, because in our case, we normally have multiple microwave links to provide, for example, a higher capacity. Then in such a case, if the Ethernet link is supported by the micro terminal, that will be the same as the left case. But if the microwave terminal can be supported by 2 microwave links, our first thought is okay, but after discussion with several experts within this week, and it seems maybe not. And so we are thinking, also seeking for more input from the working group to say how we should to model in such a case. And also if the local link collection list is the right direction, because in the topology model, it said that the local link connectivity could show the relationship between the TTP and the LTPs, but it's not. It sounds that the 2 LTP paths cannot be used at the same time. It's kind of a choose from one of the list. So we are looking for more discussion on that. And then the next step is the first one is regarding the how to make the model to be generic. And so actually we have sent the email to the list, I think in September, but unfortunately we didn't receive any reply. So it seemed to us there's limited interest to make that use for other technology, because the current author, we are just have the microwave background, and if we have to make that used to other technology, we really need some help or input with some more experts. And then another point is that for those bandwidth related data nodes definitions, we are putting them under the T-link attributes in the current version. And then it is discussed that whether we should move that to T bandwidth, just similar to what the ODN or WSUN topology model did. So this is another open issue. And of course, we welcome have 2 more view and comments. And as I think I mentioned this before, we will have a plug test under MWT, which is general next year. And those topology model and several others, such as T topology model, will be verified during the plug test. And the code implementation is starting. So, and finally, we would like to ask for working group adoption to use this draft as a starting point, so we could continue to finalize the microwave topology model. And then we also have a GitHub link, and you are welcome to visit that or send mails through the CCAMP list. Thank you.
Questions? So regarding the open issues, please resend the email to the mailing list
Yeah, we will do that.
to discuss it there.
Mm-hmm.
Regarding the adoption, well, we have a T topology for all technologies for WDM, FlexiGrid.TN. I don't see any reason why we shouldn't have one also for microwave. And it's very good that the IETF decided to use the IETF models for the plug test. So it would be nice to have the draft as a working group document before that event, which is in January, right?
Yeah, January next year.
Is anyone against the adoption of this document as a working group document? No one. So we will take this to the list.
Thank you.
Thanks a lot. Next.
Good morning. This is Hao Mian from Huawei, and I'm presenting this work on the framework on CPE control for OTN network. So CPE is actually a quite frequently used term, but now we just limited the scope to the OTN CPE, and we try to have a draft on how to define the use case and the corresponding requirement. My bad. Okay. So the motivation of this work is to address the CPE problem automatically. So we have a list of functions that need to be satisfied, including the discovery, the configuration, the connection setups, management, so on and so forth. So with the growth of scalability for CPE application, there was a highly demand on how to make this kind of jobs in an automatic way rather than integrate a lot of manual labor. So what we want is to try to borrow the idea from the IETF and construct an automatic solution rather than do it with manual stuff. So next, please.
It doesn't work. Yeah?
Yep. Doesn't work for me.
Try again now.
Oh, great. Thank you. So in this picture, we show a reference architecture of the CPE control. Just notice that the CPE location is just access to the OTN network, and the domain network, the controller, and hierarchies are something in existence with very matured architectural reference. But what we are working on here is just how to connect this one into the CPE device into. It works too bad. Access to the OTN, and because usually the equipment CPU box is physically isolated in the customer's office, but should be a kind of configured and management by the operator. So this is a kind of remote, and we probably need the existing solutions to be enabled here to guarantee the access. And moreover, if we have a special component to do the control and management of the CPE, we will have corresponding young models, including both from this control component to this orchestration system, and also from the component to the CPE itself. It can be go either via the core network or directly from the block to the CPE. And given this kind of different variation, we can easily draw some kind of variant architecture example, saying that we just put the CPE control and management component into different place. For this example shows how it is embedded in the orchestration system with the operators. And so that would allow people to configure the CPE directly from the operators, but we may need some kind of young models here to do the configuration. And the GMPRS uni is, again, we just need enable at least, and we are looking for the opportunity whether there is a need to do some extension. But for the southbound interface, for the multi-domain interconnection, there are just mature techniques here. So the summary of this work, we are trying to provide some basic background and the needs for CPE control. And we have detected the two potential directions that we may need to work on. One is the young models that need to be configured on the CPE box. And the other is the GMPRS uni protocols that need to be used to connect the CPE and the OTN networks. So both of them may have a potential need for the extension or augmentation, and we also need to understand more about the efficiency problem. So this is an initial early stage of some work. So contributions, comments, arguments, everything welcomed, and we will continue working on this and figure out the scope for the detailed work and produce future documents.
Thank you. Questions? So the problem for sure is there. We might end up with an applicability document saying, please reuse what is already there or define protocol extensions and young models.
Yep.
Thank you.
So Hao-Mian, in terms of A16 architecture, it sounds like a CMI, right?
Well, it depends how the CPU controller locates. If it
Right.
can even be as a CNC. As I said, there are many variations on the how to
Right.
draw the architecture.
But one variation is actually look like CMI, right?
Yes.
And what functionality do we need? Configuring box, CPE
Configuring
box?
CPE box, yes.
Okay,
But
I
usually
see.
this is not done by the CNC, it may be done by the MDSC.
Okay, all right, thanks.
Ito.
Thank you. Thank you. I'm Italo Usi. I'm presenting on behalf of the co-authors the draft for the YAM model to transport client signals over a transport network. We have already presented this draft in the previous IETF, and we made a few changes in the latest version. So we have updated the transport for service for Ethernet, added few service parameters like the service ID or the customer information. We have aligned the topology identifiers with the TE types, which I think is a good change. And we have added the option to configure the vendor profile either by specifying for every service the values of the CIR, EIR, etc., or to reference a named vendor profile, which were the only option in the old version. We have added the possibility to configure when a VLAN is inserted a default value for the PCP field. So it's not set always to 0. And we have added lifecycle state configuration and fixed some errors that we find during compilation. And we have also updated the transparent client services with the alignment with the topology identifier from TE types. We align with the YAM model from Yang on the layer 1 service types. So we have a common way to call the client types in the CMI and in the MPI, and added the admin status configuration. And the transport types has been aligned to create to define the type for the life cycle. So a quick recap on the transparent client signal. So we have what we need to do is to carry client like SDH, fiber channel, or Ethernet physical links. So the coding of the Ethernet, not the frames, over a transport tunnel. The transport tunnel can be any technology, can be OTN, microwave, for example. And in this case, we have no switching, we have only point-to-point port-based mapping. So what we need to say is which port is and which client is attached to and put over the tunnel. We don't need the tunnel model on the client layer, but we need maybe the topology model to say where are the access links, what are the access links that carry the client traffic that goes over the tunnel. And we have only to configure a few things like what are the access links, what is their client signal type, because we can have multi-function access links where we can configure different type of clients, and then we can say which is the transport tunnel that has to carry the client. And this a quick snapshot of the model. For Ethernet client is not non-transparent is the case where you want to set up carrier Ethernet services, for example, like EPL, EVPL, etc. In this case, you can have point-to-point or also multi-point and routed multi-point connectivity. The access links are all Ethernet-based, frame-based, but they can have different rates of encoding. So you can have a 10 gigabit Ethernet on one side and then gigabit Ethernet on the other side. Again, you don't have a tunnel model in this scenario, but you still need the topology model to know what are the access links, and we have another draft submitted to address this, but it's outside the scope of this document. And here you have to configure, in addition to the basic service and the access link, you have to configure all the classification and operations on the VLAN. You have to configure the bandwidth profile, and again, mapping to which transport tunnel that can carry the Ethernet traffic. So what we have a few comments in the past is about generalization, and the mapping between the service and the transport tunnel is already generic, because what we provide is a pointer to a T-tunnel name, and the T-tunnel name is a generic attribute in the T-tunnel model. The technology-specific attributes are all in the T-tunnel model as technology-specific augmentations. And we don't need to do any specific here, depending on the different type of tunnels. What we have is the access information is client-specific. The reason for that is that there is no commonalities between the transparent and internet client scenarios found, and more or less what we are mimicking is the same separation that we have on the CMI between layer 1 CSM, layer 2 SM, and layer 3 SM, even if we are not addressing layer 3 services. So we don't see there is any advantage to have an almost empty generic model from which we create technology-specific augmentation, which is as big as the current models. So we don't think we can do more than what we have done to generalize. Another question that recently popped up is about the difference between the tunnel mapping that we have today and the tunnel steering that was discussed in TIS, presented in TIS. We think that both options are needed. In some cases, we need to map the service to a specific transport tunnel, as in this current draft. For example, where the customer, the client application wants to specifically say, I want this service to go over this tunnel, or when you have a multi-domain technology scenario and you want to coordinate the two ends to select the same tunnel. So if you have a co-routing requirements, or you need to know from where the traffic is coming, you need to make sure that the both ends take the same tunnel, and then you need to point to a specific tunnel. But there are other situations where you want to say, I don't care about which tunnel is taken as long as it has some properties. So in this case, what you can say, I want this service to go over this tunnel pool. And one idea that we are starting to think of, but we can refine later, is to have a sort of choice. So we either point to a tunnel name or to a tunnel pool. So, we think the document is ready for working group adoption, and we can further discuss any open issues and further improvements as working group document. Thank you.
Hi, Igor Bruskin. So my question is with respect to the service definition, right?
Mm-hmm.
So when you say I'm actually putting say layer 2 VPN Ethernet service.
Yeah.
Right. So you mean by that the service as defined, say, by MEF, which is like a ELAN service? Is it correct?
Yes. Yes. Most of the services that we can support are the MEF services, but what we have also is all the layer 2 SM services on the CMI. You can support also them using this model on the MPI, or I've seen also some requirements to have a much richer capabilities in terms of VLAN manipulation at the edge that can be done. So MEF services are definitely a subset of what you can configure with this model.
So except for MEF definitions, do we have other definitions for services that when we say this is a service that we map on the OTN tunnel, we can refer to something else? Or we are talking about services that people widely understand. So basically, my question is that in my mind, it is immaterial, for example, whether the service is implemented, say, on IP network or on transport network. It is the same service.
Mm-hmm.
Correct?
Yeah.
So I like this to be very clear, because sometimes in the discussion, it becomes loose, and some people actually believe that there is one thing, it's like IP layer 2 VPN, and a totally different thing, it's a transport layer 2 VPN.
Well, it depends exactly on what do you mean by layer 2 VPN. If you think the layer 2 VPN is
exactly
the service perceived by the customer, or is the way you implement the service in the network. And sometimes people think layer 2 VPN is what the customer sees, and then I agree with you, there is no difference. If you say the layer 2 VPN is the way you implement the service over the network by using pseudo-wire, MPLS LSP, with maybe BGP and all this stuff, then it's different between IP and transport.
So the customer may not even care, right? Whether it's implemented.
But in this case, what we say is we go and look at how you configure the PNC rather than what the customer is. We are not at the CMI, so we don't define what the customer configures to request a service. We define what the MDSC configures over the PNC to implement the service.
So my point is that I know people who actually think that there is some limited version of layer 2 VPN which could be implemented on the transport network, which is some little subset of like a bigger layer 2 VPN that could be implemented on IP network. Okay, so and I'm trying what I'm getting at that it is the same service. I'm buying a service which is layer 2 VPN, which is something which limits my connectivity, which has certain TE parameters, stuff like that, but it is not really dependent whether it's supported by, say, OTN tunnels or IP tunnels, correct?
I think so.
No?
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 So yeah, to dispute a little bit that kind of assumption, I don't think it's the same. And you can kind of fix it on the way you adapt the service, which is layer 2, to what you have on the server. So for example, if you just, there was like many years ago, the GFP mapping in ODN had a limit in the size of the packet it could transport. So if you send a jumbo frame, it got lost. It's fixed now, so just bring it up as a, let's say, a past example. So obviously, if you run it on a router that may have a specific jumbo frame size, which is not very well defined, and different implementations have different jumbo sets. So there is a difference, definitely. And the same goes for the mapping itself. So how much transparency you get from your free Ethernet service. So is it packet switched? Do you really look into, for example, if you have some timing information, you really don't want to have a GFP mapped, you maybe want to have a GMP mapped, or you don't want to have it switched at all, right? So I really dispute the notion that it is the same service. It's really not, and I recall a lot of operators had a huge problem with that kind of same service, but in reality it's not.
I'm sorry. So can we discuss on the list? We have, we are behind the agenda.
10 minutes late.
Yeah.
Okay. Please continue on the list. It's very interesting, but please continue on the list.
Just one point. So basically, it would be really good if we have like a service decoupled from actually a service implementation. Okay, that's all I'm saying. Because otherwise it becomes very loose, and I don't even know what do you mean by transport layer 2 VPN.
Okay. Hi everyone, it's Chile again. This presentation is about your model for FlexE, present for my colleague Xiaobing. Yeah. Okay. Next. Oh. Okay, that's fine. Okay, this presentation is about. It's not a news one, but that's fine. So the presentation is about focus on your model. I tried to take some discussion on what can we do to FlexE technology with IETF control mechanism. The solution for FlexE control discussed in this presentation is some different from that in the framework document. So okay, next. Okay. This slide is some general discussion about the difference between FlexE and the traditional Ethernet. It's because according to a description or definition in the FlexERA in OIF that the FlexE SIM is just a built-in function in the Ethernet PCS module. If a FlexE group is set up a corresponding huge PCS module, it's created as well. So just based on this, we think that one of the significant difference between the FlexE and the traditional Ethernet is that traditional Ethernet PCS has a one-to-one relationship with the client MAC flow, while FlexE has a more flexible structure. One PCS module can be associated with multiple client MAC flow. This is the difference that we're seeing, the most significant difference. And just based on the previous slides, some analysis that we think two general control requirements that should be considered first. The first one is whether we need to configure FlexE group. The second one is whether we need to allocate the FlexE group calendar slot to allocate the resources to the client signal, that is the MAC client. Okay, just based on the, okay, next is the next slide. It's about some analysis about whether we need to configure Flex group. Okay, just based on some description in Flex ERA that when a new Flex group is brought into service, the initial configuration should be proven for both ends that to bind several different files together. So just based on the description in the Flex ERA that we think that we should use some control mechanism to configure the Flex group to create it. This is, and the next is about the allocated resources for the client signal. We raised some two questions here. The question is how to allocate the slots to each Flex client, and the second one is, does external control need to be involved? We found some description in Flex ERA. It's about some description that about the control function defined in the Flex ERA. It's, the control function can be used to put the Flex client at the source end into the Flex group into some specific slots, and then take this Flex client out at the sink end. So just based on this, we think that the Flex data plan already defined how to insert or extract the Flex client from the calendar slots. So we don't think that we need to control Flex client. This is what we want to do. And for this point, I think it's different from that description in the framework document. Okay. The next slide is about some general description about what the control plan could do. It's a summary. Some of them may not be included in current the young model draft, but I think just give a summary. We need to configure the Flex group. We need to take care of aware case, but we don't want to touch the slots. And also we should use control method to trigger the switch between different calendar slots. It's a different type. It could be A or B, different calendar type. And also some alarm that we need to take into consideration. Okay. And this is a Flex model. It's about to give a general description about the young, about the model, about the definition. This slide is about the description of a Flex group and the different slot granularity and different file bounded. It can be 100 gig, 200 gig, and 400 gig, and the different Flex instance. And next is about the calendar configuration. It could be different type. It could be A type or B type. Also some acknowledgement mode. And this slide is about some description of Flex client. But I want to give some explanation that it won't. We don't want to use this Flex client model to configure to set up some calendar configuration such as on the equipment. We just want to report the Flex calendar information to the maybe external, maybe controller after the calendar is configured at the equipment. So we just want to do this.
I'm sorry, can you jump to the next steps?
Next step, okay.
Because we're running out of time.
Okay, thank you. Okay, next step we just want to solicit more feedback from the working group, and we'll continue to update the draft based on the feedback. Something is different from that in framework document. Okay, low is there. Okay. And also I give an example here, but I want to give some detailed description. We can discuss that.
So one question for you and for Laura. Since now the ITU approved the new work item on Flex Ethernet, on a switchable Flex Ethernet, wouldn't it be the right timing to refresh the framework and focus on the framework rather than...
Well, a couple of months ago, but yes. We should have done it. We simply haven't been time to do it.
Can I give some explanation?
That's fine. I was asking for your plans.
So I have a couple of thoughts around this. The Yang model here is actually modeling something that another organization has the design authority for. So it's modeling OIF interfaces. Every other model we done in the IETF is done to model what we done in the IETF. So we know what happened when ITU stepped into the MPLS design authority. You can ask Keith Harler if you want. He can give you a very illustrative description of that. And we don't want to make the same mistake. So I don't think we should take any decision here or any kind of progressing of a document before we go to Deborah and the working group chairs sort out what type of relationship do we have with the OIF. Can we do they want us to do that type of modeling here? Having said that, I think it's a good idea because we have the Yang expertise, so we can do it. And if OIF says, okay, we don't care, or they say, well, you can do it, or actually we are very excited that you want to do it, anything like that is fine, we can go ahead and do it. But if they said, no, we want to do the Yang model ourselves, then I think we just need to stop this.
Correct. I totally agree with that.
Yeah. Okay.
Okay. Okay. Can I give some explanation about your first question?
Yes.
Okay.
While
1 minute. Okay, thank you.
30 seconds.
Okay, I would like to model FlexE and the FlexE switching into two different documents because currently in the scope of ITOT, the FlexE group is the FlexE defined OIF is defined as a second layer. It's totally different from the FlexE switch. So I would like to put it in this document. Okay, thank you.
Good morning. This is Gabriele Galimberti speaking on behalf of the quarters. I think for sake of time, I will not go through the slides. So give back the... Just to summarize, we have 4 drafts here, 2 related to LMP and 2 related to Yang models. The 2 related to the LMP are for DWDM interfaces and flex grid interfaces. The one related to the DWDM interfaces is actually addressing the application code, IETF application code, plus few parameters we have discussed with IETF in the past, and is addressing also the vendor-specific application code. This vendor-specific application code will follow probably the discussion, for sure, the discussion that are in progress with the other draft, like the Yang presentation before. The Flex Grid LMP is actually adding more parameters that...
So, Gab, sorry, I think we are running out of time. So you don't need to spend so much time on background because you have introduced this draft for many times. You can just quickly and talk about the next step.
Okay.
Maybe you have 3 minutes and 2 minutes for discussion.
Just one comment related to the Yang slides or Yang parameters, DWDM and interface. Those are actually complementary to the parameters that Jan Lee just showed before, because are more related to the equipment provisioning. So these 2 documents are complementary to the Jan Lee documents. Last, I think there is an excellent discussion in progress on all this stuff. And we, of course, we need to coordinate this 4 draft with the discussion as well. In my opinion, the best way is to follow the upgrade process is to promote the draft to working group documents and open to the other authors so that we can work all together in a set of slides that are all related together. Thanks.
Well, given that the WDM interface draft is now in a post-working group last call status, which means we'll probably go to the RFC editor queue soon, it's probably good timing to move forward the 2 WDM interface drafts. So, is anyone against the adoption of the 2 WDM interface drafts, which are in the specific DWDM interface parameter Yang and the WDM interface LMP? You have time to object also during the polling. You have time to object to the adoption during the polling.
On the list.
On the list. Okay, no particular objection. So we will run the polling on the list. So thank you, everyone. Sorry for the delay, but there was a very good and very intense discussion on many topics. And that's it. See you in Prague. Thank you, everyone. Thank you. Yes.